Hello, everybody, and welcome to the Microsoft Data and AI South Florida user group. My name is Adriano, your host, and thank you very much for making the time to be here with us today. Now, if you're first time joining us, take a minute, subscribe, like, enter your comment about the presentation. Now, during the presentation, if you have any question, use the live chat to enter your questions, and we will be answering throughout the presentation your questions live. Now, if the presentation has complete, now the presentation has completed, just use the comment section below, and we will follow up with the presenter regarding your questions. And today, we have performance tools in Azure SQL with Deepthi, who will be presenting us some great techniques where it can help us to improve the performance. Now, this will be applicable to SQL Server, performance tools, and Azure SQL. Now, without further ado, hello, Deepthi, and welcome.
Hello, Adriano. How are you?
Well, thank you. How about you?
I'm doing good too. Thank you. Thank you for having me today.
Pleasure, and thank you for being here with us. And also, thank you very much for being an organizer at the Microsoft Data and AI South Florida.
Sure.
And and where are you connecting from today?
I'm connecting from Kentucky, United States.
All right. And folks, let us know where are you connecting from. Just enter your comments in the comment section. And if you're using the live chat, you're watching right now, use the live chat and enter your location. All right, Deepthi, you'll be presenting today on, uh, there we go. Okay, on performance tools in Azure SQL. Can you tell us just a little bit, and I know you're going to go more into the details of it, about it?
Yeah, sure. So once I started learning about Azure, I started presenting, like my first ever presentation about Azure was to this user group, and I'm so glad to be here again. So what about the performance tools in Azure SQL? We have certain capabilities and features, especially in Azure, that we can take the leverage and use them for our advantage. For example, like the query store feature that is available in SQL Server 2016 and above, and also it is also available in Azure SQL. But the advantage that we have when you are in Azure is that we have the capability of enabling automated tuning options. Like for example, uh, the query store will automatically monitor your queries, and then it will force the plan for you, so you do not have to manually force the plan, which is known as like automatic plan correction. So that is especially available from SQL 2019 and above. But it is only available for the enterprise edition if you are on-prem. But if you are in Azure and if you are having Azure SQL database, then that option is available in Azure SQL database. So you can take the advantage of it. And we can also use the automatic tuning options, like for example, automatic tuning of indexes, where it will automatically monitor your indexes for certain period of time, and it will provide you the recommendations where you can take the look into like what it recommends, and whether you wanted to take the action or not take the action. It is up to you, but you still have that capability of like automatic tuning options. These are some of them. So
Very exciting there. So
yeah.
will definitely help us that use Azure SQL DB in regards to not only query performance, cost, an array of things. Huh? So that's very interesting.
Hmm.
So
Yeah.
without further ado, let's get started. Are you ready?
Oh, yes, of course.
All
So
right.
let me go ahead and
Let me,
um, share my screen.
sure thing. I see.
Um,
Give me 2 seconds. I'll take care of this. All right. It's all you.
yeah, can you see my screen in the presentation mode?
Yes, I can.
Awesome. So just in case if you if you couldn't see anything properly, please let me know. I will look into it. So thank you,
I will
Adriano.
thank you as well, and I will let you know. And when questions come about, I will keep you posted as well.
Sure. Hello, everyone. Thank you so much for taking the time for attending this session today. I would like to really thank Adriano for giving me this opportunity and for having me today to present on performance tools in Azure SQL Database. I'm one of the organizers for this user group, so I'm always honored to be speaking for my own user group. Thank you, Adriano. So, without further ado, let's get started. A little bit about me. I'm a database administrator. My name is Deepthi Goguri, and I'm a data platform MVP. And also, I'm a co-organizer for a couple of user groups. I'm a co-organizer for this user group, like Microsoft Data and AI South Florida user group. I'm also the co-organizer for Diversity, Equity, and Inclusion user group. I recently joined as a organizer for the Data TGIF, which is in Switzerland. I'm co-organizing with one of my friends, and also I do volunteer for Women in Technology as well, Women in Technology user group as well. And apart from my work and my community stuff and blogging, I like doing arts and crafts. It's been a while I didn't do it, but yeah. That gives me a lot of peace while I do something with my own hands. So and that's a lot about me. But if you'd like to contact me on Twitter, I'm very active on Twitter as well as on LinkedIn. Type by my name, Deepthi Goguri, in LinkedIn to connect with me. It would be an honor to get in touch with you. And also, I'm also available on Twitter. If you are on Twitter, you can contact me at dbnuggets. And I usually blog about SQL Server and Azure SQL topics. So if you would like to know more about it, you can visit my website. dbnuggets.com is my website. So I usually blog about T-SQL Tuesdays and um, Querystore, like extensions to my already existing sessions or upcoming sessions. Yeah, you can go ahead and look into it as well. If you are shy to ask me any questions here, please contact me later in LinkedIn or on Twitter. I'm happy to answer your questions. So before beginning the session, let's talk about like when do we call it as a performance? When do we call that our queries and our website is running fine and then perfect, right? Although it is a rare scenario where like for the long period of time, um, it is not possible to tell like, hey, this website always works fine, right? Because there are always hiccups. But when do you call it as performance is when your users um, use your application and when they click something and they get the results very quickly. That is when it calls the performance. But in behind the scenes, it is always touching the database. It can be any database. It is touching the database, and in the background, the queries are running on the server. So, in order for the queries to run faster, there are certain things that needs to be taken care of, like to run the queries faster. So, in each database engine, it can be different. But today, in our session, we are talking about Azure SQL as well as SQL Server. And when do we call it as a slow performance? Like dead opposite to the performance, right? When your users click on the application on any of the buttons that they are trying to retrieve the data, they give their parameters if there are any, like for example the date ranges, and then they click on something and it keeps on running forever, and sometimes it throw out like timeout error, right, for the users. Then you will start receiving the phone calls to the service desk people, and service desk people will open up a ticket, and that will eventually come to the DBS. But the thing when they say like it is a slow performance is the problem of the database, it might not be the problem of the database. It can be the problem with many things, like for example, the network. It can be the network issues, or it can be the Windows server level issue, or it can be the database. And when we talk about the databases, it can be the query might not be having the indexes, or it can have the stale statistics, or the resources that are on the server might be slow, because simultaneously we are also running several other different queries. It can be anything, right? So when it is slow performance, that's a big issue. So um, how do we make sure we have everything in place properly when we build any application, when we build any database, when from the scratch? Like for example, if we got a request to create the new database, mostly in this point in time, if you get a request to create any new application and a database, most of the time nobody will choose the on-prem servers, but they wanted to create the database on Azure and take the advantage of Azure because you have several advanced features in Azure. Even in the performance, the features are good in Azure. So when you are building the database, right, what kind of things you need to look for? What factors are really important? Maximum capacities, like what are the initial capacities that you want to um, uh, give it to the database, like for example the disk space, or like memory, whatever it is. What, like you not only think at the current moment but also for the next 5 years, right? You will make sure you have that capability, the maximum capacity is available. And when you are building the database, you have the store procedures that will be running on your tables. You need to make sure there are proper indexes. No matter if you are on prem or in Azure, the database tables are exactly the same. Where they are hosted is different, but how the queries are executed is exactly the same. So you need to make sure the indexes are in place, and the statistics that are on the indexes and the statistics that you have on the tables, those are up to date as well. And if you are using the business critical database, um, you have the in-memory OLTP available, and this is only if you are using the business critical tier. For the other tiers, like the basic tiers, general purpose, and hyperscale, you do not have that option. But if you are using the business critical, then you have the in-memory OLTP, and you can use partitions for the tables. And lastly, you have intelligent performance available in Azure, especially in Azure, and we are going to talk about that in this session. So I'm not going to dive deep into this slide, but there are certain tiers available in Azure. On the left side of your screen, you can see like the service tiers that are available, like the general purpose, business critical, and hyperscale. And what are the compute and the storage, and what are the backup capabilities, and what are the features that are available. I have provided it clearly, like the maximum number of capabilities and capacities available here. You can look into the slide later. I'm not going deep dive into this slide because there are a lot more things to talk about in this session. But this slide will give an overview of what are the maximum capacities available in each of these tiers. As we discussed, like there are like maximum capacities and what are the factors are important, but there are also other things to consider. Like for example, the TempDB. If you are having the Azure SQL database, it also uses the TempDB for your queries. So in Azure SQL database, if you choose the Azure SQL database, the maximum number of files you can choose for TempDB is 16 files. And if you are using the managed instance, it's 12 files in max you can use. You can choose the size and the number of files you want to choose, but you cannot choose where it is actually located. So you can't access the drive location where the TempDB is placed. And make sure like like if you are using the Azure SQL database, if you are building the Azure SQL database, the tempdb files are always placed in the local SSDs. That's a standard because by using the local SSDs, there is low latencies. So that is the reason why Microsoft uses the local SSDs for the tempdb. And when we talk about the database configurations, you can, if you are building the Azure SQL database, you can use alter database scoped configurations. And the database is always placed in the full recovery model only because they have to provide the service level agreement um, from Microsoft. So it has to be in the full recovery model. You can't change that. And if you are using the Azure SQL database, you can use the max top query hints. Not only the max top, but you have several other query hints that you can use. But according to the like database configuration things, you can use the max DOP. So what does this query hints does is like by using the query store, you do not have to change the underneath code within your store procedures, but without touching your code itself, by using the query hints for query store, you can use the query hints like, for example, the recompile or like max stop um, kind of options that you can choose. Like these kind of query hints you can use. We are going to talk that in our demo as well. And when we talk about files and file groups, again, you can add and change file sizes, and user defined file groups are also available. So when we talk about the performance, when like in the perspective of the database contains the tables. So the tables have indexes and statistics. So when we talk about the performance, it all goes again into the tables as well as the table components that we have, like the objects within the database and the tables. No matter if your database is in on-prem or in the Azure, it all goes again to the tables and then the objects within the tables, which are like indexes and statistics. So as an overview, like if you're not really familiar with what happens when we have an indexes or what happens when we have statistics and what will happen if you're not updating them properly, I would like to give an overview by talking a little bit for a couple of minutes on indexes and statistics. So when you build an index, it will automatically build a statistic on the top of that index. So if, for example, if you have an index on a column, you will automatically have the statistics get created on the same exact column. But not only that, you will all like, for example, like you are running different keys for the first time, SQL Server will analyze and automatically build the statistics based upon like what you are querying. So for example, like if you are if you are running a select statement and doing a where clause, on the where clause, you are using a particular column and you're searching on that column. The statistic will automatically get created on that particular column on which you are searching for. So that's like how the statistics are built, right? But then, if your automatic statistics are enabled on the database, that means like a certain number of records have to be updated so that that automatic statistics would kick in. And by default, like whatever default value you have set in place, it will go ahead and update the statistics with that default value. It can be full scan or it can be whatever percentage you have placed. But what will happen if you, though your auto stats is enabled on the database, what will happen if you do not manually run the update stats? So whenever the the mechanism that happens, like how the statistics are used in your queries, is, for example, you are running a query for the first time on the SQL server, a particular query, let's say. Before even running that query, the SQL engine will actually go ahead and look into the statistics. It will directly go ahead and look into the statistics to see the flow of the data, how your data is distributed. So it will go ahead and make an estimate of how much data it might be pulling, and it will allocate the certain resources, like for example, the CPU and memory resources, even before executing the query. So let's say it will go ahead and make an estimate, and it will give the estimate, and then it will allocate the resources for the query, and those resources are used by the SQL engine to produce the results. So that is the process. But what will happen if your statistics are in stale? What if your statistics are not up to date? Then your statistics are out of date, and all the results that are in the statistics are not accurate. So let's say you are running a query and your statistics are stale, and you are about to get 1,000 records in real, but then the statistics are saying like you will only get the 100 records because they are out of date. So based upon those statistics, the SQL server will only allocate the resources based upon that 100 records. But actually, while the query is actually executing it, those resources are not enough because it have to grab 1,000 records in real. So that will cause a problem, right? The type of execution plan that gets generated because of that will be totally different, because the statistics are out of date, the estimations are totally out of whack. So that will cause a problem because the number of resources that are allocated for the query to execute are less, but it requires more. So it might use the other resources like tempdb. It might be spilling into the tempdb, it might be spilling into the disk, and the execution plan might be using different operators instead of using a different simple operators. It might get complicated, and it might hit the performance. It might affect the performance of your queries. And once you receive like the service desk call saying that hey, this query is not running fine, you might be thinking different things, like what might be the causing the problems, the resources are proper, and you will search like what else is running on the server and everything seems normal. But like let's say you just forgot about the statistics and you are searching everywhere. It becomes difficult because as your statistics are out of date, all these other things are happening that will affect the performance. So whenever something happens, right, whenever they say the performance is slow on your queries, there are certain things that you have to first focus on. And one of them, the first thing that you have to look at the statistics, whether your statistics are up to date for those tables that are used in the query that they are running. First thing that, and next thing is what is the execution plan? Go ahead and look into the execution plan. Whether creating an index can actually improve the performance. Do not trust like the suggested values of the indexes that shows in the management studio, but just because most of the times that column that it is suggesting is already in there. Like the index might be already there, but it might be coexisting with the other columns. So you do not want to directly go ahead and create the suggested index because you might be duplicating and affecting the performance. So you need to be very careful. You need to also look into the execution plan and see if there are any spills going on, if the data is using the tempdb or if it is spilling to the disk. If it is spilling to the disk, it's a representation of like your statistics are out of date. So you need to look at the statistics. So that's the importance of like indexes and statistics here. But how do you maintain and manage these indexes and statistics when you are in Azure SQL database? You know that when you are using on-prem SQL Server, you have SQL Server Agent where you can create the maintenance jobs by using the free tools like Olahel and Grin scripts or any other maintenance tool that you are using in your environments. But then, like in Azure SQL, you don't have you don't have SQL Server Agent. There are ways that you can still maintain the indexes and statistics and still maintain the maintain the automated jobs that you wanted to do. So there are a couple of ways where you can do it. One is like Azure automation, and the other is like Elastic Agent jobs. Today in this session, we are going to see like how you can create the automation jobs. So before creating the automation job on your Azure SQL database to maintain these mm, indexes or statistics, you need to be having like some of the prerequisites. You need to make sure you have these prerequisites available. The prerequisites are like, of course, you need to have the scripts, the maintenance scripts that you need to make sure you execute them, you have in place in your database. The next thing from the Azure perspective is you need to have the automation account. Very simple to create the automation account. And once you create the automation account, you need to download like a module, download the SQL Server module from the marketplace. And then you need to create a credential. What credentials are you going to use to run these jobs? You need to have that credential in place, create the credential, and then use that credential by creating a runbook where you have the query. You are telling, like in the runbook, you will mention the query that needs to be executed against the database, along with the credentials that you will be using to run that particular job. So I took a screenshot instead of going ahead and showing it in the Azure portal. It's exactly the same. I'm going to show you in the screenshot, which will give you a very clear idea of how to do it. So I have downloaded the Ola Hellengren scripts from online. It's free. So once you download, it will show you a bunch of stored procedures to create. You just execute it and you will see it under the stored procedures under your Azure SQL database, right? Once you do that, go to the portal.azure.com. If you do not have a subscription, you can sign it up for free. You'll get around like $100 of credit, and for 30 days you can use and test it out. If you have subscription, then that's good. That's great. You can go ahead and search in the search bar for the automation account, and then I'm not going to show you the step by step, but I'm going to show you like what all details you need. You need to give the details of the subscription, name of the automation, of course, and then in what resource group you want to create this particular automation account, and then the region. The region should be in sync with where your database is, so that it will have no effect on the latencies. And uh, and then hit on create to create the automation account, which is very simple. Now, do you remember that I said like you need to download a SQL Server module from the marketplace? So search for the SQL Server module, and with couple of clicks, you can just download. Like um, it's just like the extension tool on your Chrome, right? It's similar way. You can download and then do the clicks, and then your module is available. Now, after that, you need to create the credential, right? What credential you want to use. So go to the automation account that you have created, and then on the left side your screen, on the left side pane, go to the credentials where you want to create the credential. Click on add a credential, and then give the username and like what is the password, so that you can create. Very simple to create as well. Then later you want to create the runbook. So I grab the script from the Microsoft website of how to create this runbook. So go to the automation account again, and on the left side pane, go to the runbooks, click on the runbooks, hit create a runbook, and then while creating the runbook, you already have the credential, right? But then you don't want to hard code that value inside the notebook. So you want to create two variables. One is for your account, what account you want to use as a credential, what database, like the database as a string, as well as the SQL Server as a variable as well. And you need to create these variables underneath the automation account. Left side your pane, you'll see the variables. Create those two variables that you will be using. Here I'm using the database AdventureWorks and the SQL Server. That's my logical SQL Server name. And then while you hit on create the runbook, you will be providing this exact code. I took it from the Microsoft website, and there is an article of how to create that. It's very simple. Like if you see here, I have provided my credential. DTP is an account that I want to use to run this particular notebook, and then the SQL Server variable, and then the database variable. And if you see the query that I'm executing there, I'm simply executing. If you see the last line in the query, you see like I'm just executing the Azure SQL maintenance and couple of variables over there like operations. I want to do all the operations and then log to a table, and then I'm providing the query timeout. It's as simple as that. And then I would like to schedule this one. When do you want to run it? And then I would like to create the timings, and then um, if you want to create any expiration date, like when it has to stop, you can do that. Hit create. But then here I would like to manually run the job to show you like whether it will actually work or not. So I created a table which is sales order detail enlarged underscore new table. And what I did for this particular demo was like I inserted a lot of data. So as I told you, like if you do certain number of inserts into the table, then if your if your indexes are like, um, if your statistics are not up to date, like if you are not doing auto update stats, then it won't it won't update the stats. You need to always make sure you turn that on, like auto update stats. But here I did like a lot of inserts, which will actually fragmented my uh, did the fragmentation on my indexes. If you see the first screenshot, it shows the database ID, object name, and the index ID and the index name. And if you see the fragmentation level, as I did a lot of inserts, there is huge fragmentation over there. So what I did was like I checked when was the last time I actually updated my indexes. Updated my stats. If you see the table name, statistics ID, and the stats, as I did not update, as I did not enable the auto update stats, it did not trigger that, it did not execute it, so it shows everything as null. So what I did was I would like to manually run this particular job. So I went to the runbook that I created and I hit on start, which actually executed the job. And then I rechecked my index fragmentation right now. And if you see the as the indexes get, because the runbook, if you see like the query inside the runbook, we made sure like operations as all, like take care of the indexes, do the index organization, and like reorg, as well as you also can update the stats at the same time. So it went ahead and it reorganized the indexes or rebuild the indexes based upon how much uh, fragmentation that you have set up in your queries, in the maintenance plan queries. So it did the job. Like if you see the fragmentation level is 0 point something, and then if you see when was my statistics lastly updated, it has actually updated. And I did that with the full scan. The scan percentage that I mentioned in the query in the maintenance plan was to do the full scan. So if you see the number of rows and rows sampled are exactly the same, that is like the full scan, meaning it did the full scan. So that's about like how you can actually work on the maintenance jobs while still using the Azure SQL database where there is no SQL Server agent. Now let's go to the next performance tuning feature, which is known as Querystore. So in this slide, I'm going to give you an introduction of Querystore if you're not familiar. So Querystore feature is actually introduced in SQL Server 2016 and above. And since then, they have added a lot of features in it. So this is actually a database level feature and not the instance level feature. So if you are in 2016 and above, you need to manually go ahead and like right click on the database and enable the query store so that this feature will be enabled. So what will happen once this query store is enabled? It will go ahead and collect your queries and not only the query but the execution plan and the resource information like the what is the memory used, what are the other resources that are used. It will capture all of that information and it will put in the query store. So there is certain amount of space that you will allocate for the query store. You can control how much space you want to allocate for that query store. But once you enable, you can either capture every single query, like including the ad hoc queries, or you can choose like only once it hits certain limit, like once it executed this number of times, go ahead and capture it. Or um, based upon how much of resources it uses, then go ahead and capture the queries. You can do that like mix and match. Um, you can go ahead and select the exact like what do you want to do, like what do you want to capture. So it will continuously capture those queries and it will capture those since the time you enabled it. Over time it will capture that information. So what is that advantage? The advantage is that you can clearly see the execution plans that it is being generated. Execution plan can change anytime based upon certain things, like if you rebuild the indexes, that will trigger it to trigger the SQL engine to generate a new execution plan. If you update the stats, that might trigger the SQL engine to generate a new plan. Or like if you flush out the plan cache, or if the plan is overwhelmed, if the plan cache is overwhelmed with, if it is full, then SQL Server will automatically remove the least used execution plan anyway. So your plan might be gone, and then SQL engine will again generate a new plan whenever you execute it the next time. So it will collect the information over time, and you can also give when to clear out the data, oldest data. You can do all sort of those settings. But then because it will capture all of this information, you have the capability of like whenever you are having performance issues, like whether a particular if a particular plan that is currently being used is not working fine, you can go ahead and look into what was my last execution plan, and you can manually force that last good plan with your own hands manually. You can do that. But the next level advantage of it is like if you are in 2019, SQL 2019 and above, and if you are using the enterprise edition of SQL Server, or if you are in Azure SQL Database, then there is something known as automatic plan correction. This is an advanced feature in Querystore. So instead of you going ahead and look into the plans and seeing what was the last good plan, forcing the plan, like if you're having any issues, then only you'll take care of like you'll take the advantage of query store. Like if something happens and if your plan is not working fine, then you will go ahead and check what was going on, what are my plans within the query store. That's when you will take the advantage of query store, right? But then with the automatic plan correction, you do not have to manually go ahead and look at what were the plans that were good and whether the plan has been changed, whether the forced plan that you have forced, is it still being used, right? Because there are always chances of like SQL Server to generate the new plans and then use the new plans um, because there are certain things that you also have to focus on once you manually force the plan in query store. There can be failures within the query store. Doesn't mean that your query will fail. Your query will never fail. by the way. Like if you're having any issues within the query store on your force plan, it will go ahead and generate the new plan. Like SQL engine will go ahead and generate the new plan, but it will never fail the query just because you forced a plan and SQL engine doesn't want to use that force plan. It doesn't fail your query, because if that happens, then what is the feature, right? What is the feature and what is the advantage of the query store? Everybody will be scared to even enable the query store, because it there are possibilities to fail the queries, right? But that doesn't happen. Your queries will never fail. The failure reasons will be captured within the query store, and SQL engine will just go ahead and create the new execution plan and use that new execution plan, but the queries will never fail. But the advantage with the automatic plan correction is you do not have to worry about like whether the plan that you forced is still being used or whether you need to actually force a plan. Because at this particular time, like if you are in 2019 and above in Enterprise Edition, or if you are using the Azure SQL database, then Querystore will automatically go ahead and look for the plans, look for the last good plan, and it will always force the last good plan. Like let's say something happen, like update stats happen, rebuild of indexes happen, and SQL engine decided to build a new execution plan for your query. Now you do not have to worry about going ahead and seeing whether SQL engine has generated a new plan. But here, this query store feature will automatically go ahead and look for the new plan, and it will compare whether the last good plan that I actually forced is still good or whether the new plan is good. If the new plan is good, let me go ahead and unforce the last plan and then force the next good plan that got generated. Like, for example, it can be the worst plan than before, right? So if it is not good plan that got generated, it will still keep the last good plan in place and will go ahead with the flow. It will go ahead and continuously monitor the execution plans. It will continuously do that for you. So it is the automation, right? You do not have to worry about anything. So, um, by the way, the automatic plan correction, I mentioned that it is available in 2019 and above, but it is 2017. I'm sorry, I just got confused. It is 2017 and above, but then it is only available if you are in Enterprise Edition. Now let's go ahead and see the demo of this particular um, feature, automatic plan correction. I'm going to share my management studio, and I'm going to show you how it actually works. So I'm in the Azure SQL database. I'm connected to the Azure SQL database. If you see here, we are using AdventureWorks database. So the automatic plan correction is automatically enabled in the Azure SQL database, but how do you how do you want to enable it if you are in 2017 and above, and if you are having Enterprise Edition? I just want to show you the query that where you can enable it. So all you have to do is alter the database name, set automatic tuning, force last good plan to be turned on. That will actually enable automatic plan correction. So let me go ahead and do that on Azure SQL database. By the way, it's automatically enabled here, but I would like to show you how to enable that. And then let me go ahead and create a simple store procedure. If you see it here, I'm just selecting a couple of columns and searching on a product ID. So let me go ahead and do that. If it exists, it will drop and recreate. And I have to do that in the database. So let me connect to AdventureWorks database, execute that. So if you see, so I have enabled that, but if you see here, the automatic tuning options, I have also executed that. So it gave me the results here. So the force last good plan is turned on, meaning the automatic tuning is currently on. There are also other intelligent performance features that we are going to discuss is create index, drop index, and maintain index. Um, it can like this is an um, automatic intelligent processing as well, like intelligent performance feature. It will give the report of like whether it is a good idea to create the index or drop index. It will give you the report where you can go ahead and choose what action to take. You can either take the action or ignore the action, but we still have that option in Azure SQL Database. So let's see the first one, force last good plan. So we created the store procedure, right? Now I'll go ahead and clear out my query store. So before clearing out the query store, let's go ahead and see the how the query store looks like. So Adventure works, go ahead and refresh that option, refresh the database. If you see here, you see the query store folder. Expand the query store folder. You have um, certain reports that are available. Go ahead and click on top resource consuming queries because I'm going to see everything here. So here are a couple of things that got captured while I was running this, but I would like to go ahead and clear out. So you see the data and everything is currently shown, right? So I don't want to see this bar graph where I have to hover my mouse to see the query. I don't want to do that. I just want to see the query. So to do that, go ahead and click on this, um, click the bottom and see the tabular model, like view top resource coming in grid format. Grid format will show you the exact queries that we're running, right? So I would like to go ahead and clear out my query store. Clearing query store is simple. Alter database name, set query store clear. Do not do this in production. This is my demo, so I'm doing it very simply, but because it will clear out all the data that you have captured until then. So I have cleared out, right? So I'm going to hit on refresh, which will clear out everything, right? So that I can start my demo. Now I would like to also clear out my procedure cache. I would like to clear my procedure cache because the next query that I'm running, if there is already an execution plan in the procedure cache, it will go ahead and use that plan. I don't want it to use that plan. I want to create the procedure, like create the execution plan in fresh. So let me go ahead and clear out my procedure cache. Now I would like to show you how the automatic plan correction works. To show you how the plan correction works, we need to create the workload because the automatic plan correction doesn't take the decisions just for one execution. It has to execute at least couple of times. That metrics, like how many times that it have to execute, we do not know that. Microsoft, that internal information, it's an internal information. It will go ahead and monitor. So we do not know how many times we need to run exactly, but I would like to run it couple of times to make sure like automatic plan correction hits and then take the decision for us. So I would like to run the store procedure that we built with one of the parameter like 942. This parameter is really parameter sensitive, meaning I'm using two parameters 942 and 707. These two have a lot of difference. One parameter gives like couple of records and the other one gives like some thousands and thousands of records. So let's see. I executed the first workload and then check the results. And if you see the number of records that got generated, it gave me bottom of the screen. If you see bottom right, it shows 385 records, right? That's very low. Now I would like to go ahead and see my Querystore, refresh it to see it captured the plan ID. If you see, then the size of the circle is really big. That's the execution plan, by the way. But the circle is really big. Now, why is it so big, right? Because I executed it for 50 times. If you see the execution count here, it shows 50. So the more times you execute, the bigger the circle is. So it executed for 50 times and it generated the execution plan here. If you see index seek and key lookup. All right. Now let's go ahead and clear out my procedure cache because I would like to force the execution. I would like to force the next execution to create a new execution plan just to make sure my automatic plan correction actually is working in my demo. But in real time scenario, you do not have to do that. I cleared out my procedure cache and I'm running the next regression, creating the conflict in between the two executions. Now, if you see, I'm running it for the 10 times. If I execute, the number of results that it generates is totally different. Previously, we got 385 records, but this time, if you see, it will give like bigger number. It's still executing. I'm running it for the 10 times. Now, if you see, like it generated 237 thousands of records. Huge difference, right? Now, let's go ahead and refresh this because it will capture both of the execution plans. So the next execution plan is plan ID 2, but if you observe something here, it went ahead and it forced the last good plan. So when you see the next plan here, it is doing the clustered index scan using the parallelism clustered index scan. Clustered index is like it scanned the entire index. So it thought like, well, the query that has actually executed the second time is only 10 times. But most of the times, the query that executed was for the other parameter, which executed for 50 times. So let me go ahead and force the plan because it compared both the resources, how much of duration, average duration, how much time it is taking, and it compared both of them and it forced the last good plan. And I did not force anything. It did it automatically by itself. That's how the automatic plan correction works. And the next time it runs any other plan, it will go ahead and make sure the last good plan is always in place. Now, how do we know like why it has actually forced the plan, right? Why it has chosen the plan ID 1 to be forced? You can find the reason by running the select star from sysdmdb tuning recommendations, this particular query. By executing that, it will give certain results, um, like the forced good plan. And what is the reason? Why did it choose to force that plan? Is because the average CPU time has changed from 1.38 milliseconds to 753 milliseconds. So it has hit the threshold of the CPU time. Again, we do not have that internal information, but it clearly shows there is this threshold that it have to hit to to take the decision of changing the plan, like forcing the plan. So this is the reason. And if you drag your mouse, it will also give you the query, the exact details. So if you can copy those details and then paste it here, right? Paste it here. It will give you the entire like what query has actually been executed. It executed execute SP query force plan for the query ID 5. It used plan ID 1. So the background, this particular query has executed. You can also manually execute this particular query, but when you are using the automatic plan correction feature, you do not have to do that because it will take care of it. But if you are not using automatic plan correction, you can still run this query and see the recommendations. And you can go ahead and you can execute it manually if you want. So that's how the automatic plan correction works. Let me close this. And also let me show you how the Querystore hint works. This is also a Querystore feature. And we are still using the Azure SQL database. I'm going to connect to the Azure SQL database, right? And right now, to show you how the query hints works, let me go ahead and drop and recreate the existing store procedure that I created. Let me do that. And then let me clear out the query store and then let me clear out the query store and procedure cache. User does not have permission to do this action. Why is that? Because I'm still connecting to master database. Let me go ahead and do that on the database, clear out the procedure cache. Okay, I did that. Now, let me go ahead and execute the same store procedure with two parameter sensitive queries and two parameter sensitive. These are parameter sensitive. Again, lot of difference between the execution number of records. So let me go ahead and show you the actual execution plan as well. So I included the actual execution plan and execute this to see the results. If you see, the first execution has given me 360K records. The second one have given me 385 records. And if you see the execution plan here, the first one which got generated, which gave us like 361K records, it chosen to do the clustered index scan. But the second execution that I used has only given 385 records. But if you observe here, it's still chosen the clustered index scan. Do you think it is really required to do the clustered index scan for just getting that 385 records? No, right? So why do it has to do that? There is a reason why it has chosen to do the clustered index scan the second time, because the first time the query has run, the first time this particular uh, uh, the first time we executed the store procedure after recreating the store procedure, right? We have recreated. So the first time it executed, it has actually created the execution plan and it has placed the execution plan in the plan cache. The next time you run the same store procedure, no matter what parameter you use, it will still go ahead and force the same execution plan. But is it really required here? It is not required because it is taking a lot of resources to do that clustered index scan just to get that 385 records. So we don't want that. So what do you usually do if you do not have Querystore enabled? You can do the recompile option, right? It can hit the performance because it is still doing the clustered index scan, but when it doesn't have to, and it is taking a lot of resources, and when you're having other queries running on the server, it can hit the performance. Like your performance can be slow, and then users might be complaining like, hey, I'm running the same store procedure, but with this particular parameter, I don't know what is going on. It's taking a hell lot of time, but it only have to give 385 rows. So why is it taking so long? Is because it is still using the clustered index scan. And to fix that problem, we usually do the recompile option, right? So to do the recompile, we need to touch the query of the store procedure. We do not want to do that. So by using the query store feature, you can take the advantage of query hints. And so as you are using the query store, there are certain store procedures especially designed for that query hints so that you do not have to touch the code, but then use those store procedures and then take the advantage of it. So all you need was the query ID that you are running and what hint you want to use. That's all you need. So to find the query ID for this particular store procedure, right? I need to use this query and search on the query text by using the like operator. I grab some amount of the query text that I used in the store procedure and I have executed this query to find out my query ID, which is query ID 1 for this particular store procedure. So I got the query ID. Now I would like to use the SP query store set hints store procedure, especially designed for this query hints, and then use the query ID 1. We know that query ID, right? The query ID for that particular store procedure is query ID 1, and I would like to use the option recompile. Give the value of the query hint that you want to use. So I would like to use the recompile. I'm not even touching the store procedure code. All that I'm using is execute sp query store set hints, give the query ID and the value that you want to use as a query hint. So now let me go ahead and execute that. And then you can see what query hint is active currently. So to do that, you need to run this particular query to see what query hint is enabled. So in the results, you see the query hint ID is 1 on the query ID 1 and the query hint text is option recompile. So currently the option recompile is activated on that particular query ID, which is a store procedure, right? Now let me go ahead and execute the same store procedure with the same parameter again to see how it is actually acting. Execute that and see the execution plan currently. So the first time, as we are using the recompile, right, it has sensed the parameter. And for the first one, which has given us like 361K records, it chosen to do the clustered index scan because that is how it have to do for those many records. That is a good decision. But the second one, did you see the difference for previous, like before enabling the query hint and after enabling the query hint? After enabling the query hint, it did the recompile and then it chose to do the index seek and the key lookup just for that 385 records that we received. If you see the second execution is still 385 records. So that's how, without even touching the code of your store procedure, you can still take the advantage of query hints by using the Querystore feature. But now I would like to use a different query hint. To do that, you can actually use the max stop. Like if you want to use a max stop one, that is one of the query hint, right? If you want to do that, again, use the store procedure, give the query ID, which is one, and use the option max stop one. But what will happen once you do that, right? I would like to see what is currently active again, what hint is currently active. Now, if you see here, it has updated the hint ID. Before we have query hint ID 1, but now it is query hint ID 2. And the current active hint is maxed up 1. But where is this, the previous option that I have chosen, which is recompile? How do I even know what was my previous hint? Let's say for some reason somebody has changed the query hint and you would like to go back and revert it. How do you even know which query hint was being used? That is not captured here, but you can still take the advantage of extended events to capture that information. To know how to actually enable that extended event session and to capture the history of the query hints for the query store, visit my website dbanuggets.com and go ahead and click on query store tab, where you'll find the list of a list of blog posts I have written, and one of them will be like how to actually enable the extended events to capture the history of the query hints. So currently max.1 is active. So let's go ahead and um, run the run this particular executions again. But before that, I would like to clear out my cache. And now let me execute the same store procedures again. Execute. Now, if you see the execution plan this time, and then go ahead and right click on select, go to properties. If you see here, the max stop is set to 1. And for both of them, if you see the properties, the max stop is set to 1 because you are every time the query runs, it will go ahead and use that particular hint. But if you observe here, we removed that option of recompile, right? We removed that hint. We updated that with max stop 1. So it went back, it reverted back and it executed clustered index scan because the first execution given us the 360K records and the second one is 385 records, but it still chose to give the execution plan as clustered index scan again because we removed that hint. We updated with max of 1, so it has only used the latest query hint. It did not use the recompile hint. So how about you want to use both of them because you want to take the advantage of both of the hints? Can you execute both of the hints at the same time? Yes, you can do. So execute with the option recompile comma max.1 will actually activate both of them. So if you go ahead and see the query hints what are active, it will actually enable both of them. but the query hint ID is still 3. The history is not captured. So let's go ahead and see how it will actually act this time. Let me go ahead and clear out my cache again and execute the same stored procedures again to see the execution plan. Here, the first execution, as it produced many records, it chosen to be clustered index scan because that recompile option hit. And then the second one, it recompiled again and did index seek and key lookup, which is cool, right? For this particular execution, it is cool. And then did it actually use the max drop one? Yes, it also used the max drop one for both of them. If you see the properties, the max drop is set to 1. So you can use the multiple options, multiple query hints at the same time. But if you want to clear out the query hints that you set on particular store procedure, all you have to do is like sp query hint, query store clear hint, and give the query ID. That's all. If you execute it, it will go ahead and clear out um, all of the hints that you actually enable on that particular query ID. If you see, the results are gone, but you can still have the history if you enable that extended event. Even though you removed, you still have the history. So you need to take the advantage of that. And if you would like to know what all query hints are active by using the query store, you can go to this link to see the available query hint options that you can use. That's all demo regarding the query hints and well as the automatic plan correction. Now let me go ahead and share back my screen to see the other options. So, like I said, there is also the intelligent performance features like automatic tuning options that are available, like for example, the create index, drop index. So to see that, go to the portal.azure.com and hit on your database, Azure SQL database, which is AdventureWorks here in my case, and then go to the intelligent processing. Like you'll be having like intelligent performance on the left side panel, and you can see the create index recommendation that is shown here. So let's see, for example, it has given the create index. So let's go ahead and see the details of it. Click on it to see like the recommendation. Like on the left side pane, if you see, like you need to go ahead and click on performance overview under the intelligent performance to see these particular recommendations. So click on that particular create index recommendation and see the details, like on what column it is suggesting and what is the impact of it. If you see, it shows the high impact. If you would like to automate this, right, you can click on automate on the top of it to go ahead and automatically create index. This is just a recommendation, it has been given to you. You can either automate it or you can just discard it. So if you click on that particular index that has actually shown here, right, create index, click on that to see more details, like what is the index name, index type, what is the schema, what is the table name, and on what columns. And you can also hit on apply on the top of it to apply this create index. Or you can also discard it. Like if you see on the top, it also show you the discard. Discard meaning it will not take any action. It will just ignore it. There is also one more important feature, which is query performance insights that is available in Azure SQL. So what you have to do is go to the AdventureWorks database, Azure SQL database, left side your pane under the intelligent performance, click on query performance insight. This is just a way like you have like monitoring tools, right? Like for example, Itera monitoring tool DPA that you have. If you have one in your company that you use, purchase and use, it's the similar way. But if you are using Azure SQL database, you can do that within your Azure SQL database query performance insights. So this is how it looks like a bar graphs, but all the queries that are taking lot of resources will be shown in this particular pane. For example, I would like to click on query ID 61 to see more details into it. So as I hit on that particular query ID 61, it will clearly show me what is a query, what is a CPU, what is a IO, and what is a what are the other details, like what is the execution count and how much time it took and what are the resources it took. It is similar way like it shows in your other performance monitoring tools as well. So I believe I covered most of the performance tools that are available in Azure SQL Database. But at this point of time, I would like to open up for the questions if you have any. But I would like to really thank Adriano for giving me this opportunity to speak at our user group, as well as thank you again for having me, and thank you everyone for taking your time in this evening to hop into the YouTube channel and then watch live on like to learn something new about the performance tools in Azure SQL. Thank you.
Thank you, Deepthi, for being here with us, sharing some great knowledge.
Mhm.
So on an amazing presentation here, where we learn about performance doing Azure SQL and even some that can be used on SQL Server 2017 Enterprise and 2019 and higher. Some great, just a quick review here. You touched the statistic management, understanding, execution plan, index maintenance, query tuning, and optimization. Then you went way and beyond there and just like talk covering Azure Automation Runbook, automated maintenance jobs, Querystore features, automatic plan, correction, intelligence performance, to query performance insights, also in Azure SQL as a tool. And we didn't even talk, and to top all of that, you used it and you displayed by showing with hands-on demos.
And one more point that I would like to mention I didn't add that in my slides. I'm planning to make a entire new presentation on SQL Server 2022. But for this particular feature, Query Store, if you are using SQL Server 2022, then you need to remember that any new databases that you are creating on SQL 2022 will automatically have Query Store enabled. They made that as a default option, that it will automatically be enabled. But if you are migrating your old databases to the new environment, then you need to make sure you manually enable Query Store on the SQL Server 2022, but any new databases will automatically have that enabled, and you can modify based upon your needs and take the advantage of Query Store. And all the Query Store hints that I am mentioning are available on SQL 2022 as well. And in 2022, the other advantage is like if you're having the readable secondaries, the Query Store if you are having the query store, it will actually have the data captured on the readable secondaries as well.
Awesome. Awesome. So there we go. Some great insight there on how it all behaves and how one needs to look at and use and this approach on SQL Server 2022. And looking forward to your presentation there on SQL Server 2022, folks. Stay tuned. Check out Deepti's blog and follow her on Twitter. Just check out the description below. It has all of that information, how to get in touch with her on LinkedIn, Twitter, blog, etc. All right. That's great information. If you watch this, you're for watching the presentation right now, remember, like, subscribe, add a comment, and remember to come back and rewatch the video because it is mind-blowing the amount of knowledge Deepthi just shared here. I mean, just easily list like 10 things, and as you watch it, you will see even more. So take your time. Really great information there, and that's free information for you, where you can get even deeper in terms of your knowledge by checking out Deepti's blogs. Follow her on LinkedIn and Twitter. Anything else that you want to add, Deepti?
I would like to thank everyone, and I'm going to present on new topics in coming months. So if you want to learn more about it, I usually present at different user groups and conferences for free. So if you want to know when I'm speaking, just you can follow me on Twitter or LinkedIn is where I usually publish where I'm going to speak next. So yeah, you can stay tuned to watch out more on that platforms.
All right, can you do me a favor, Deepti? Do you still have your slide that has your? Oh yeah, it's right here. Yeah, that has your. Hold on a second. Let me see if we can do that. Awesome. Sorry about that. So, folks, there you are. You have Deepti's Twitter, the blog address, and the LinkedIn. Reach out, ping her, follow her, check out her next presentations, and be prepared to be amazed. Some great information here. All right. So, folks, let me take a look here to see if we have any questions on the live chat. And remember, during the presentation, use the live chat as we are reaching here the end of this amazing presentation. And as you watch the on demand, use the comment to enter your questions. We'll follow up here with Deepti to get that address for you. And remember to like, share, and subscribe to the channel. All right, let's take a look over here. I don't see a question at this point. So thank you all very much for attending the amazing presentation here from Deepti on Azure SQL Performance Tools. And thank you, Deepti, very much for making the time to be here with us, sharing this knowledge with the community, the members, and those that will come after and watch on demand as well.
Thank you for having me, Adriano.
All right. Without further ado, folks, I will see you all. Take care. And till the next. Bye bye.